Hello and welcome back. This is A-Level Computer Science 9618 Paper 3 Chapter 6 Artificial Intelligence, and this is part 1 because this AI chapter is too much complex for me to put in one video. Okay, so we will start with graph, which is Dijkstra's algorithm and A-star algorithm. We will start from here. And why do we use this algorithm? We use it for finding the most shortest path, okay, between any 2 points from start to finish. So let's begin. Let's start with Dijkstra's algorithm. This is a node. These are all nodes connected to one another. These are all cost to go from one node to another node, and this is the starting position. This is the finishing position that we need to reach here. Okay, start to finish and find the shortest path. Let's start from here. Right in front of you, this is the label, the name of these vertices. This is telling us the sequence that the sequence that we are following, 1 2 3 4 etc. This is the cost that we are telling, that the cost from coming to the starting position from starting position is 0. Okay, so I'm going to write it down here, 0. Now let's see. First of all, I'm going to start from here and I'm going to see that which is the least cost to go from the starting position. Right now I can see here that it is, if I reach from here to here, it is 5. If I go from here to here, it's 6. So 5 is the most least cost. Sequence number 2, cost is 5. Again, I will just repeat this again. I will keep on repeating this until I get this my destination. Starting from again, from the starting position, 5 and 4. So 5 and 4, which means it's going to be 9. 5 plus 6 is going to be 11, and 6 coming here is 6. So which is the most least? 6 is the least, so I'm going to put sequence number 2 and 6 is the cost again, and I'm going to highlight this. Now starting again, 5 4, which is 9, 5 6, which is 11, and 5 okay 6 and 7, which is 13. I can write 13, but 11 is less than 30, so I'm not going to write down. 6 plus 6 is 12, so I'm going to write down 12, which is the least number. 9 is the least, so I'm going to do this. 9 is the least. Okay, so 1 2 3 4 is the sequence number and 9 is the cost. Starting again, if I go from 5 plus 4 plus 12, what will I get? 5 plus 4 just 9, it's going to be 21. Okay, 5 plus 6 is 11, 5 plus 4 plus 3 is 10, 11, 12, it would have been 12. 6 plus 7 is 13, so 11, which is coming from here, and okay, this is 21, this could have been 13, this 11 coming from here, this coming from here would have been 13. 6 plus 6 is 12, which one of these is the least? This one is the least. Okay, so I'm going to shade this path because only because of this I got 11. Okay, 5 plus 6 is 11. So sequence number, okay, this is 1, this is 2, this is 3 actually. This is actually 3. Okay, and now this is going to be 4. Least is the cost is 11 coming from here. Okay, now going again. Okay, 6 plus 6 is 12. 6 plus 7. Oh, I'm not doing this. 6 plus 6 is 5 plus 6 is 11. 11 plus 5 is 16. Then if I go from here, it would be 21. If I go from 11 plus 6, it would be 17. Okay, which means I got the shortest updated path. If I go from here to here, it would be 17. If I go from here to here, 11 plus 5, it would be 17, which is the least path. either it is this, I mean, which one of these is the least part? Okay, this one is cancelled because this is updated, the value is updated. 17 or 12, I'll just say it is 12, so I'm going to highlight this. Okay, so this is the sequence number 1 2 3 4 5. I should have written 5 in here. Okay, and this makes 6. The cost is 12. Okay, starting again. 5 plus 4 plus 12 is 21. If I go from 11, then it would be 17. If I go from here, it would be 20. So 70, which means this line should be highlighted definitely. So I'm going to highlight this, and finally I got the whole setup. 1 2 3 4 5 6 7. So I got 7 here. This is the cost. Okay, now what we're going to do is we're going to see that what is the shortest path. So I'm going to, if I want to create the shortest path, then this is the shortest path. Boom, this is the shortest path. Here, then going here, and then going here is the shortest path. Okay, this is the answer. This is how you try to show in the exam. Another way of telling the shortest path is, let me just do it. So B or C, I'll choose B because it is 5. So I'm going to circle this. I'm going to highlight this. There you go. Let's highlight this. And okay, after highlighting this, I'm going to update it. A, B. Okay. 6 will come down because 6 will come down. D, the D value would be 5 plus 4, which is 9. So I'm going to write down 9. The value of E would be 5 plus 6 is 11. So I'm going to write down 11. F is infinite because we cannot reach it yet. So it's infinite and infinite. Okay, starting again. Now, A, B, C. Okay, so I need to choose any from these. So 6, I'm going to choose 6. Just A, B, C. So I'm going to write down A, B, C. After choosing C, what should be the value of D? After choosing C, which means I just need to highlight this. Now, what would be the value of D? Again, it's going to be 9. I'm going to write down 9. As for part E, 6 plus 7, which is 13. Okay, 5 plus 6 is 11. So again, it is 11. F, the value of F, 6 plus 6 is 12. Write down 12. G, cannot reach here. Cannot reach yet. Now, choosing any from these, which is the least. This is the least. So circle this. A, B, C, D. Okay. I just chosen D, so I'm going to highlight this again. Now, A, B, C, D. Now I'm going to see the value of E again. 5 plus 4, 9 plus 3, which is 10, 11, 12. 5 plus 6 is 11. 6, 7 plus is 13. So 11. E will remain 11 because it is the most shortest one. Then D, F. Coming from here, it is 12. Again, it is the same value. And this would be not, G will be updated now. 9 plus 12 is 21. Highlight this. A, B, C, D, E. Okay. Then I'm going to highlight. Okay. So I just done this. Now, let's see again what should be the value of f. 12. If I come here, 9 plus 5 is 9 plus 5 is 14, so 12 is the best option, which means it will remain 12. So 12. What should be the value of g? Coming from here, it's going to be 21, but if I come here, 11 plus 6, it's going to be 17. So 17, the value is updated. Choose any one of these. 12 is the most least, which means 12 is the most least, which means you're going to highlight this as well. Now, if I choose A, B, C, D, E, F, last one is 17. So 17. I mean, if you just see it for yourself, 21, 17, and coming from it, 12 plus 8, which is 20. So 17 is the best option. There you go. And this is your answer. There you go. This is how you do it, and you can just see it for yourself that these two questions are the similar thing. The only difference is the graphical way that I've just done it, and also it's a little different, but it will give the same answer. It will give the same logical answer. Okay, finding the shortest path. You can just see it. You can just see it for yourself. 5 plus 6 plus 6 is 17. Is the shortest path. 17 is the shortest path. Okay. Now, I have done Dijkstra's algorithm. It is used to find the shortest path between the starting point and the finishing point. Okay. So let's start with Dijkstra algorithm. In the Dijkstra algorithm, it's quite similar to Dijkstra's algorithm, but the difference is there are two things to understand. Whenever you try to find the shortest path, you need to put two things in your mind, that you're going to see the total number, the sum, when going from one node to another node. First thing is the cost, which is Gn, is the cost. Okay, the distance between two nodes. What should be the cost? How much cost will it took to go from your home to your university? 500, 700, or $5 or $6, something like that. So distance between two nodes. Okay, node A, node B, which is represented as Gn. Movement cost. What is Hn? Hn is this. This is Hn. This is your Hn. Okay. How far we have to go to reach the destination most effectively, which means that if you have this, and let's supposing this is the movement cost, and we have Hn, or suppose Hn is just telling you that how far is the node from the destination point, which means, for example, you have this grid, and this is a starting point, this is a finishing point, and the heuristic value would be, if I just try to see the distance, 1 2 3 4 5 6 7 8 8, it is 8. Okay, 8 and 1 2 3 4 5 6 6. So 8 plus 6 is how much? 14 is the heuristic value, is the value that it will is the distance from this position to this position, the distance. Okay, the distance that you will have to go through. It's only telling us the distance, how far we have to go. How far we have to go? Sorry sir, how far we have to go? Oh, we have to go from 8 and then we have to go 6, which means we have to go 14. The cost, okay, the distance, we have to go 14 meter or 14 centimeter or something like that, 14 units, 14 boxes. Okay, So this is hn, this is gn is a movement cost between nodes, and h is telling us that how far this node is from the destination point. How far is this node from the destination point? This is the destination that we need to go. It will go something like this, it will go something like this. The hn should be 11, this should be 15, something like this. Okay, now there are two things to understand. The first thing is, if you could be asked to generate your own GN, your own movement cost, and generate or find, you could say, your own heuristic value HN, which the scenario is the scenario of, if you ever get these kind of scenarios, that I mean, right here, this is a scenario that we need to calculate our own GN and HN. Okay, but sometimes you should they also give you the values like these are HN, okay, and these are GN, the movement cost between nodes, the movement cost between nodes, the movement cost, which is GN. HN is the destination from this position to this position, 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 like this. Okay, starting from here. Now supposing, find the shortest path using Dijkstra algorithm. Create your own GN and HN. How to create our own GN and HN? Calculating HN is pretty damn easy, because you just only need to find the distance between the starting position and the finishing position. So right here 1 2 3 4 5 6 7 8 box, and then 1 2 3 4 5 6 8 plus 6 is 14 units. That is the destination from this to this. Now how to generate GN? Depending on this scenario, by looking at this this grid, this scenario, we need to calculate GN. Okay, so how will we going to do it? Supposing that you can go right, you can go down, you can go up, you can go left. What should be the movement cost between these two boxes? What should be the movement cost between these two boxes? And also you can also go sideways. What is the movement cost between this and this? The movement cost. Okay, so according to the textbooks which I just read, they have done something like this. Wait, this is a triangle. You can just say this should be 14, this is 10, this is 10. Is, I mean, even if you just use a calculator like 10 square plus 10 square, and then you can just going to do under root, and then we are right on 14 here, that it should be the value should be at some point should be 14.14, but we have just written it down to 14. We have just generated our own GN. So this is how we are generating it. So if we go, if for example this is our point, if it goes this manner, it will, the cost would be 14. If we go this manner, it would be 10. If we go this manner, again it would be 10. Okay, sideways is 14, sideways is 14, going from here to here it is 10, from going from here to here it is also 10, sideways is 14. Okay, now let's begin. Supposing I need to go from here. If I go from here, the cost would be 10, and also I need to see the distance. The heuristic value would be 13, because you're shifting right, you're decreasing the distance from the from the destination point. So I need to have different values. For example, let me just copy it down to make it easier for you guys to understand what I'm actually doing. It's very easy, we just need to understand the concept, that's all. So for example, find, if I just show you the gn values, what would be the gn values? Okay, going from here to here, it would be 10, this would be 10, this would be 14. Here it's going to be 13, since you're decreasing it, 13. Here it should be 12. Okay, yeah, this should be 12. 13, 12, 13, 12. Okay, so I'm going to now calculate the sum. Fn is equal to gn plus hn. Okay, 13 plus 10 is 23, 13 plus 10 is 23, 12 plus 14 is 26. So I'm just going to down either down or right, depending. I mean, you can choose your own. So supposing I'm choosing this one, so I've chosen this. Okay, go on to here. So now my beautiful point is here. Again, I'm going to see it. So it's going to be 10, it's going to be 10, it's going to be 14. And this is also going to be 14. Okay. The gn values, it should be here. Supposing that I have taken my distance, okay, so I'm going to take, so I'm going to put in here, can go in here, it's going to 14, 13, 12, 14, 13, again 13, 12, 11, should be 13. Okay, now if I could just see it now. Okay, 12 plus 10 is 22, 12 plus 10 is 22, this should be 27, this should be 25, 20 to 22. So I'm going to go down here. So in the first, let me just calculate each and everything. In the first step, I went right. So in going right, which means 13 plus 10. So 13 plus 10 is 23. Second step, I decide to go down. Okay, going down, which means 12 plus 10, which is 22. So what I have just done here, I have just gone to here. Okay, so 12 plus 10 is 22. Now let me show you something cool, something that I have been waiting for a long time to show you this whole example, just to make sure that you just understand what is happening. Now we will come to the conclusion. Now supposing that for initially my point was in here, and I would have gone from here to here. Okay, what I have done here, that I just take right and then take left, even though I could just go from here to here. Okay, what was the cost of going right? The cost of going right was 23. What was the cost of going down was 22, which means it took me at least 45 45 value, 45 cost, you can say. Going here, then going here, it cost me 45 units, I mean 45 number value cost me this much. 22, sorry, 10 plus 13 is 23. Yeah, going from here it's got to be 45. Now what happens if I could just going from here to here diagonally directly? What would have been the cost if I would have gone from, I just in the first it was right and then it was down. What happened if I would have taken this? What would have been the value if I, supposing from I was in here and I just go from here to here, the value is 14 in the GN, but in the HN it would be 12, so it would be at least 26. Okay, 12 it is in the HN, 13 12 and 14 which is from the GN, so 14 plus 12 is 26. Now you can just compare it. You can now compare it. 26 in here, 45 in here. Which was the least amount? This is the least amount. This is the longest amount. I just put all the hard work going from right and then going from left, taking extra cost 23, which is 45. Instead, you could have just going from here to here, which would have it would have cost you 26 units. You can say 26 values. Okay, so if we keep on going like this, if we keep on going diagonal, we can just reach much faster and less cost in a less cost. Okay, so that's what I wanted to show you, and this is how it is done in the textbooks. So now let me show you the final answer. The final answer would be that you will go diagonally, and if it is possible go right and down, but right here you will go diagonally. So going from here to here, then again it's blocked, so you're being forced to go from here in this, or wait, not go from here to here, then here on here. You have finally reached the destination. It would have been it would cost you lesser, instead of going like this and this and this and this and then this and this and this. It would have cost you much more, but in this way it is costing you much less. So it was 26 going from here to here, 26 and 14, 13, 12. Let me just show you different example. Let me just show you. Okay, me make another copy. Now in the HN value, this is the HN heuristic. Okay, the values should be like 13, 12, 13, wait, 12, this should be 12, 13 should be 11, 10, 9, 8, 7, 6, 5, 4, this is 4, this is 3, 10, 9, 8, 10. Okay, 6, 7. Okay, 6, 7, 9, 8, 7, 6. This should be 10. This should be 9, 8, 7, 6, 5, 4, 3, 2, 1. It could have been much larger. Still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Should have been 13. Sorry, but okay, but still it doesn't matter. So it was 13 actually. So it was 13 total, but it doesn't matter. Okay, so if it was 13, that would be 12, 12, 11, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. It would have been 2, and this would be 1. Let me just do it again. It won't make much of a difference. Okay, If you go from here, then it would be 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, this is how it is working. So 8, 1, 2, 3, 4, 5. I mean, the total is actually 13, but still doesn't matter. It's fine. I hope you guys understood this. Okay. So whenever you try to calculate the heuristic value, it is actually 13 values. Okay. So this is how you're going to do Dijkstra algorithm. Whenever you've been given a clue that you need to find your own GN and HN, this is how you generate HN and GN. Okay, HN is very easy. GN is that you just simplify. You just do it on your own way. Okay. Now this is another question that it has given you the GN as well as the HN values. Okay. So this is these are labels. The node, there's a node number, the cost from home to this, which is node to home, node to node, which is G. The heuristic value, the total. Starting from home. Okay, starting from home, which is this. The cost from home is 14. Heuristic is the cost from home is 0 actually. Heuristic is 14. Total is 14. Now if I go from here to here, the cost is 4 and the heuristic value is 9. Okay, this is 13 and this is C. If I go from home to A, the cost is 1. Cost is 1. Heuristic is 10. This makes 11. If I go from home to B, the value is 5. So cost from home, this is 5. Heuristic value is 7. The total number is 13. 8, 9, 10, 11, 12, 13, which is the least. This one is the least, which means I'm going to choose this road. Done. Now since I have just chosen this road, I'm going to see from here which is the least by looking at all of this. So again, starting from starting to B again, seeing the B value, and now this is the cost. So going from here to here, it would be 4. So I'm going to write down 4. What is the heuristic? Heuristic is 7 again. So going from the value is here, the heuristic is 7, so I'm going to write down 7. The total is 8, 9, 10, 11. 8, 9, 10, 11. Okay. If I go from here to here, what should be the cost? The heuristic, the cost is 1 plus 6 is 7. This is E actually. 1 plus 6 is 7 is the cost, and heuristic value is 3. This is 10. Okay. So starting from here it was 11, and coming from here to here it was 10. The total. We are only seeing the total. Okay. So this is the lowest. So highlight this. Okay, now seeing from here, E to F is, if I just say F, what should be the cost? 1 6, which is 7, 7 to 7 plus 1 is 8. 8 should be the total cost. Heuristic value is 3. 9 10 11. What should be the cost from here to here? 5 1 6 7 8 9 10 11 12. 12 should be the value if you're going to school. Okay, 1 6 1 6 7, I mean 7 plus 5, which is 12. 12 is a total cost. Heuristic value is 0. So what should be the value? Is just 12. Just the lowest. This is the lowest. I'm going to choose this F. Choose an F, which means highlighting this. Now seeing from here, okay, I've only just got one node. So going to home, I mean the school. So calculating this school, which means 1 plus 6 7 8 9 10 11. 11 should be the cost. Write down 11. The value, heuristic value is 0. So this is 0 and this is 11, which means this is the least. It's the least one. So this is the answer, since we have reached this. So this is the answer. This is how you do Dijkstra algorithm, and this is how you do these, So this was Dijkstra algorithm, and Dijkstra algorithm is much more, it's much better than the Dijkstra algorithm and much more flexible, much more, for complex stuff, Dijkstra algorithm is much more preferred. Even in GPS or in map, in Google Maps, Dijkstra algorithm is used. Okay, so Dijkstra algorithm is much better, much more efficient than the Dijkstra algorithm. This was part 1 of artificial intelligence chapter 6. Now see you guys in the next video starting from here. Okay, so this was part 1, so congratulations.